get started. Okay, so hi everybody, my name's Dave Johnston. I am currently the Opus IVS 360 technical support for the Jag Land Rover brand. Just going to do a short webinar today on the Ingenium engine, mainly focusing on the diesel today. I'll do another one in the future on the petrol. But at this point in time, just want to do a quick overview of the engine, the reason why, a little bit of the reasons why JLR decided to build their own engines and use them, and why. And we'll go from there, and we'll see how you go. Okay, so if you have any questions, there's a chat box on the side there. You can just put them in. I'll try to get to them at the end and answer as many as I possibly can. Obviously, if I can't, I'll get some details and try and forward you the answers in the future. All right, so we'll kick it off here. Like I said, I'm just going to do the Ingenium engine diesel at this point in time. So we'll start off basically just an idea of what you can expect to see on the new Ingenium diesel, so the Ingenium I4 compared to the old 2.2. The look and feel of the engine's a lot different. The way it's built, manufactured, and how you pretty much work on it is a lot different to the older ones. You'll see as we go through the differences that you'll see between the two as we go along. So I'll just put up here just some general specs of the difference between the two. So in my opinion, it's a simpler designed engine. Some of the work may take a bit longer, you know, like to do change, you've got to pull a gearbox out on these ones. So, but the way I see it, it's a simpler, easier engine to work on. The 2.2 was always a bit dubious, in my opinion, to work on. So some of the differences, you've got a chain driven now, rather than a belt driven. You'll see there the specs for the mid spec. It says slightly lower power, but you're not going to notice it. And the eco obviously a little bit more power. The oil spec has changed for the new one. It's a lighter weight, obviously, and what you'll see is the fuel capacity is a bit more. That's always a good thing on JLR product, as everybody knows they're prone to leaking. So, you know, it's better to have more in there at the start. It's more to run out before it goes dry. So we'll just look now at what some of the applications that have these and what sort of year they started from. So as you can see there, they started back in the XF on a 15 plate. Through the range, obviously, they're putting them in the newer cars now. And, you know, you can say what you want about the Defender and what they're doing with that. They've obviously realised that they don't want to keep it in that, and they're diversifying a bit there. But the range that we're looking at the moment is this. And as you can see, across the board, they've all got them in. So let's have an idea of, you know, why JLR went to using their own thing. It's basically all about carbon footprint, and obviously they need them to be as low on producing emissions as physically possible. So JLR built a £500 million purpose-built engine building plant in the UK, and that was purely to design and build their own engines to reduce all of the emissions that they could probably get out of the engine without using anybody else's stuff. They propose that they'll get their emissions as low as 99 grams per kilometre. It can't be far off that now, to be honest. Some of these new features that we'll go through today will give you an idea of how much they're taking out of what they've used previously to try and bring down the power that the engine needs to produce to make it work efficiently. So as you can see there, that was Wolfgang Seibert. He's the group engineer for JLR. That was his public announcement of why they're doing it. So pretty much, as you can see, it is what it is. So let's look at some of the features that we've got on the Ingenium. They've changed a few things to try and improve the way the engine works, reduce breakaway frictions, and obviously get it to its running temperature as quick as possible. All of that obviously helps the way that the engine runs, doesn't have to work too hard, therefore doesn't produce as much emission. So as you can see, we've got roller bearings on the cams, electric coolant and oil pumps. It's got exhaust cam phasing. Somebody did ask me a question the other day, why hasn't it got both? On a diesel engine, you don't need power. The power's already there, so they only need to phase the exhaust for emissions. And new feature for this engine, and I think completely for the JLR range, is a low pressure EGR system. We'll go through a couple of these obviously as we go through, but yeah, you'll get to see what they look like and, you know, some of the issues that we are seeing with them. So we'll just have a quick look at the cam. The cams are a hollow cam, obviously with weight reduction, and they run on a bearing now, so it reduces the breakaway friction when the engine's cold or at a standstill, so from start. This enables then, you know, the engine not to produce more torque to try and turn the cams, so it lowers the emissions. That's how fine they are getting on this now. All of these little things need to, you know, all come together to reduce the emissions as far as they can get it. So as you can see, the roller bearings there, they're a hollow cam, as I've said. Pretty easy now as well. When you take these apart, the cam caps are numbered and lettered, so you can't get them wrong, you know. So it's pretty much easy. It goes, you know, you've got I on the cam cap for inlet, E on a cam cap for exhaust, and they're numbered 1 to 4. So, you know, you unlike when somebody used to come across and you got your engine stripped and they'd knock your bench and everything and go everywhere, and just line them back up. Now they're all numbered, dead easy to do. Okay, so we'll move on to one of the things that I think is a great idea, is electronic coolant pump. I don't know if any other brands are using this. They probably are. I wouldn't have thought why they wouldn't be. But the JLR brand, we're using this in this engine, and it seems to be doing the job really well. I've only seen a couple of issues with them, and that's purely, you know, for the solenoid. Not a wiring, but just the solenoid's packed up. So the coolant pump pretty much is controlled to give minimum flow to support the coolant requests, aid quicker warm up of the engine. Obviously, the engine gets to its warm up, its running temperature quicker. It's going to be more efficient. So the way this works is the shroud slides over the impeller to prevent the coolant from being pumped around the engine. It needs internal pressure to move the shroud. So obviously your impeller spinning creates that to move it, but it's controlled by the solenoid as to how far it can go. The solenoid's obviously powered from the ECU, and the signal is sent by a pulse width modulation to control how far it lets that shroud slide over. As you can see there, it's pretty simple by design. So yeah, we'll just, you know, we'll take a quick look at how it works. The warm up is obviously aided by an electronic thermostat, but we don't need to look at that. Everybody's seen an electronic thermostat before. Okay, so as you can see here, if you look at component A on the diagram, that's engine coolant, the outlet to the engine, and B is from the inlet to the pump. So if you take a look at that there, so if we go onto figure 1 there, you'll see that that's completely open. The flow goes straight in and straight out. That's with the shroud completely off the impeller. On figure 2 there, you'll see that that's 50% open, so it's reducing the flow to the engine, obviously creating the engine to warm up quicker. And on figure 3, you'll see there that that's fully closed, therefore there's no flow out to the engine. So obviously the engine, the coolant that's in the engine at this point in time, getting heated up quicker, and obviously getting the engine to its running temperature. Now, the default, if it does fail, obviously it's going to be 100% open. They did think about that. You don't want to cannon an engine because the thing's closed and obviously it boils up. So they did get beyond that and go, right, if there's a failure in any of the electrical component, its default will be fully 100% open. So yeah, look, if there's any questions, obviously put them onto the questions area there, and I'll try to get to them. But it's pretty self-explanatory when you look at it on the diagram and the way it works. So it's not really too much. I just think it's a great idea to have, and if it's controlled right, obviously it will do the job really well. So another feature of this Ingenium is obviously it's chain driven, and as I said earlier, to do the chains on this, you're removing the gearbox, because the drive for this engine is at the back of the engine, or what we propose to be at the back of the engine. So as you can see, it's got upper and lower chains. They're joined by an idler sprocket in the middle. So the primary chain, which is the lower chain, is driven by the crank and drives the fuel pump and the idler, and the secondary is driven by the middle idler and drives the cams. Issues, well, we'll get to them later. The whole job, again, we'll go through later on. I just want a quick overview here, but the whole job is, yeah, it is what it is. You've got to pull the gearbox out, the flex plate's got to come off, and the rear cover just to get to these chains. But again, we'll address that later on. Now, I'll move on to another one of the ideas that I really like is the low pressure EGR. As we all know now, you've got your DPF and you've got your AdBlue, SCR or DEF functions, which create a lot cleaner waste coming out of the exhaust. This is just an added bonus to that. So basically what this will do, and we'll go through now, and I'll just show you some pictures. So, and it'll say there on the screen there. So after the DPF, the cleanest part of the exhaust gas is then filtered back through toward the engine. It goes through an EGR cooler, obviously because it's going to be hot air going into it. Goes through the EGR cooler and then straight up and straight into the induction for the turbo. This again draws the bit of waste that comes out after the DPF back in through the engine again, reburn, all to help reduce the emissions, and that's why it's done. It's like I said, it's all about getting cleaner driven vehicles out there. So again, if you've got any any questions, just pop them up there. At this point in time, it's not too hard to work out the reasons why JLR do this and why other brands, I'm sure, are following suit. It's what the people want and it's what the planet needs. So, the cleaner the cars, we've got millions and billions on the road at the moment. So, we can reduce what they do or what they pump into the air, then it's better for everybody. Okay, so just quickly, just want to pop over now to some of the common issues. Now, I think a lot of the guys that I've spoken to recently that are starting to see these will understand what's going on when I come through this and the reasons why I'm doing this. It's not massively in depth. I'm just going to try and give a bit of an insight as to what people are seeing and a bit of an aid to get a bit of a right diagnosis. So one of the major points to these, and this is why I brought up earlier that the timing chains are at the back there, is because they do suffer with engine noise. Not necessarily always the timing chains. So I'm going to bring this into an idea of getting you how to diagnose the difference between the two, and obviously the difference between engine noise and turbo noise. Now, if we move forward onto noise diagnostics now is done in a completely different way as to when I was a kid. Gone are the days where you've got a screwdriver to your ear listening to the engine. Jag Land Rover now have adopted the process of using NVH for noise testing, so noise vehicle and harshness testing. So that takes the use of a Pico and obviously a noise testing kit. You can physically see on the scope where the noise is on the engine. So if you've never used this or you've never heard of it, worth investigating, guys. Our company does supply this. I'm not trying to do an advert here, but our company does supply this, and you do get trained on it. JLR now adopt this process, like I said, this is how it's done in dealer world. There is no more electronic chassis or, you know, a screwdriver interior, or even to the point of a stethoscope anymore. This is how it's done. As I'm aware, they will not, you know, warrant any diagnostic unless it's done correctly with the tools that are provided. So, but I do understand that not everybody's got it. So the way we're going to go through the diagnostics today is old school. So as I said, if you've got a Pico and an MVH kit, fantastic. If you don't and you've got some chassis or electronic ears, brilliant. If not, a stethoscope, good as any. Or again, if you're like me, back to the screwdriver to the ear. So first up, we know this is an issue. I think everybody's heard of this issue. I think it's been widely publicized. Balance shaft noise. To the point that Jag Land Rover on their Topics website have got a diagnostic video to assist the technicians with finding out if it's balance shafts. There is technical service bulletins on balance shaft noise, and if you look through the workshop manual, it's got its own area of how to do the job. But anyways, we'll just go through our way of diagnosing it. So basically, the first part of it, you'll hear the noise. A customer will complain of a squeal from the noise or a squeaking from the noise when they rev it up. So again, you've got a couple of options to go with. You've got to, first up, is it the balance shafts? Is it one of the drive components, alternator, you know, water pump? So first thing we do is verify the area of the noise. For me, I always suggest removing the drive belt. So that rules out any of the driven components on that part. So again, you know, your water pump or your alternator, or even a tensioner or a pulley. Now, with the balance shaft testing, you raise the speed up to 1800 RPM, sorry, and then back to idle. You'll hear the squeal come in and you'll hear it fade out. Raise it again, 2000 RPM, you'll hear it come in and it will be louder, and then it will phase out as you come back down. The noise from the engine will follow throttle response. So if you rev it up and hold it there and then let it off and it disappears, or it fades out with the idle drop, it is engine based. Turbo noises don't follow throttle response. They're delayed from throttle response. So you rev an engine up and you've got a turbo noise, and you'll hear that whistle, you let your foot off. As the turbo spools down, the noise won't follow immediately engine speed. It'll drop off at a different rate. So that's how you can tell the difference between turbo and engine. So yeah, again, so we've done the test, we've localized the noise to the balance shafts. Now we've got to look at the repair. Now, as I said, the balance shafts, you've got to do from the backside of the engine. You don't have to remove the chains, but you do have to take out the gearbox and the plate. So the JLR standard time for this is approximately 9 hours. I'd strongly suggest that you don't follow that as a given. JLR times, and I've found this running a JLR workshop for 10 years. And a friend of mine actually does standard times in the UK. These, unless you've done more than one of them and you've done them quite recent and you've got all the special tools and everything's laid out, you're never going to do it in 9 hours. But again, as it says here, there are special tools. It's carried out with the engine lowered and not removed. So basically it's just transmission removal. Hold the engine up on a cradle. There is mandatory components to be replaced, such as washers, stretch bolts, and the likes. And I always suggest this, and I don't see why you wouldn't. If you're doing a job of this magnitude, review the topics procedure. You can get topics for an hour. You know, you pay for it for an hour. You can go in, you can print out the procedure. You're not going to miss anything. It tells you everything you need to replace. It tells you the special tools. And it tells you the tightening tools, all the specs, all you need. So again, I always suggest that if you're doing something for the first time of this magnitude, advise checking the proper procedure on topics. Okay, so The noise will not log a DTC. It's just a standard noise that you're going to have to deal with, and anybody that works on these engines will have to deal with them at some point. Just got a couple of pictures here now. I do apologize about the focus of them. As you can see, this is the balance shaft. You can see how hot that's got. That is where your noise comes from. The heat that's gone into this balance shaft is exactly why you get the noise and why it follows. Because as you know, as a wheel bearing, the noise is there once it's done. This next slide here, if you have a look there on the drive for it, you can see where it's actually burnt into the metal. So that's how hot these are getting. So you can understand the noise and why we're why we're having to replace these. So that's that bit done. So now we'll move on to another favorite of mine, timing chain noise. Timing chain noise, again, it's pretty standard. I think you all know what timing chains sound like when they're gone. You just got to make sure that it's not obviously cam bearings rattling around, or you've got a valve gear noise or something. So again, pretty standard. As you do it, you've just got to get the vehicle to an operating temperature, turn it off, let it sit there for 30 minutes, start the vehicle and try and isolate where the noise is coming from. If you've got an MVH tester, obviously you'd have clamped that side of the engine. You'd be able to read on your scope where that noise is coming from. Same as chassis is, or your screwdriver at the back there. Obviously localize it, make sure it is to the timing chain area, because if you pull the gearbox out and it's not, you're going to be kind of upset and have wasted your time. So if you verified that, again, that's it. If it's at the rear of the engine there, timing chain, procedure. So again, this procedure, as I've stated, standard times, yeah, okay, 8 hours. No, again, you're not going to do it in 8 hours. Always allow yourself enough time. Because, yeah, if you haven't got all the kit there and you've done it before, it's going to be a little bit of a job. So, again, special tools are required. Carried out with the engine in place again. Same again, timing chain remove. Mandatory component replacement, spring washers, stretch bolts, and as we said before, I advise on checking the topics procedure for this. Now, with the timing chains, this may throw codes in it. You might have cam or crank DTCs logged, depending on the chain tension and condition. Not always will you. It might just be a noise again. So, all right, that's a couple of noises. Now we'll move on to engine management light. Now, engine management light, again, some of the basic tools that you will need. At a JLR dealership, obviously, they will have a picoscope because it's mandatory tooling. They will have a smoke tester. It's mandatory tooling. As far as we go as Opus IVS, these are the things I'd strongly suggest that you should have in your workshop. This will aid diagnostics immeasurably. Smoke tester is pretty standard for working on Jag and Land Rover cars. It's probably the same on pretty much every other brand, but for me and the way I aid diagnostics with people, if you haven't got a smoke tester, invest in a smoke tester. Many reasons why, but again, you can find any leak on the engine exhaust with a smoke tester. Picoscope, obviously the autologic tool, and a multimeter. You're going to need a multimeter anyway, if you've got one, cool. If not, they're not that expensive anymore. But anyways, we'll move on to the low pressure EGR, which is, I have now seen a fair few problems with this. The reason being, and you'll see on one of the slides later on, the idea is great and the way it works is fantastic, but in my opinion, and it's only my opinion, I'm not a designer, but they've come up with a filter, obviously, because you don't want debris going into the turbo. That filter is what I'm seeing a lot of problems caused by, and again, we'll go through that now. So these are the codes that you will see. Straight up again, smoke test the induction system, make sure there's no air leaks. If you've got any air leaks, fix that first, because it can all contribute to the DTCs being logged. Once you've sorted out you've got no air leaks, no exhaust leaks, check out your DPF remaining volume. if, as you see there on page 8 on dynamic data on these vehicles, you'll see that it's got all the measurements for the DPF there, because obviously a blocked DPF is not going to help. So it might give you a little bit of back pressure, which is not going to help your low pressure EGR. If that's all good, clear it, retest it. If the light comes back on, then you've got to replace the filter. There's a Land Rover technical service bulletin for this. The JLR standard time is 3 hours. I strongly suggest this is not far off the mark. It's not a hard job to do. It's a bit fiddly, obviously, because everything's tight on these vehicles, but it's not far off the mark for 3 hours. Again, though, if you've never done one, leave yourself a bit more time, because yeah, you've just got to work out how it works. But once you've viewed it and you've seen it and you've done it once, 3 hours is pretty fair time. Again, the technical bulletin there, that's the number for the technical bulletin. You can view that on Topics if you've got a subscription to Topics, or even if you go on to find out a process, look up that technical bulletin. But basically, it'll give you the testing procedures, which is pretty much what we've just been through. And then it will give you the filter to replace and the inlet outlet gaskets and blah, blah, blah. And then there is a reflash on the PCM to the latest software. I've seen these fixed by just replacing the filter and sending it on its way. I've seen them fixed by just doing an update on the PCM, but the technical bulletin suggests do both, so that's what I suggest. Okay, so the reason I said about the filter earlier is because this image here that I'm about to show you now, as you can see, that's not blocked, in my opinion, that filter. You can see through it. So it's not fully blocked, but that is enough to bring the code on. The replacement filter in this, literally they put a new filter in this car. It fixed the problem without a PCM. So that's how light that they have to get blocked up. And this car had done, I think it was 57,000 Ks. So they're blocking up quite regularly. They need a clean out or a new filter. I do believe that the PCM has changed the parameters for our sensitivity it's picked up, but again, this wasn't too blocked and it's bringing up. So yeah, PCM update. So that's just a couple of things, guys, and I just wanted to do a quick overview and a run through. Again, has anybody got any questions, throw them up now. I'll try and answer them as best I can. If not, obviously look forward to more training courses and a bit of feedback if you didn't think this one was long enough, or it wasn't as in-depth as you wanted or whatever. Always accommodating. We can run it again with a bit more depth later on, or we can do a new one completely, or we can do whatever you guys are looking for. But just suggestions is what we need. We're here to help and give some ideas back to you guys to try and help you do your jobs. So throw it up and we'll go from there. Okay, just going to go with a quick question now from Georgina. Can they be cleaned with additive? Yes, they can. How effectively you clean them, depending on what you're using. They have got a rubber seal around them, so I'm not sure how effective they will be on the sealing after that, but it's always worth a go. I'm not saying it's not. I've known people that have cleaned them out and it's gone away. So yes, they can, but obviously get something that's rubber friendly because the seal will diminish. But other than that, yeah, no, you should be able to give it a go. But again, once you've got it apart, you'll probably not want to put it back together and take the risk. But if you can't get the parts, sure, give it a go. Okay, so any other questions? No? Okay, well, thanks for joining, guys. And like I said, any suggestions, throw them out there. We're all good. We'll take on board and try and create some more content for you, a bit more tailored to what you need. If we get enough shouting for a certain, course, then sure, we'll go amongst and get it. So, all right, well, thanks for tuning in, guys. There's pretty, it's not as in-depth as you thought it was going to be or whatever, but there's some good testing procedures and stuff there. So take it away with you, mate. And yeah, we'll see how you go. So if there's no more questions, all right, well, thanks for coming and cheers. Take it easy.